Chapter 5, the Thermochemistry. The objective of this chapter is to calculate the energy released or absorbed from a chemical reaction. So we have to calculate Q, or what we call delta H, and if the value is negative, we say that the reaction is exothermic. If the value is positive, the reaction is endothermic. This is the first part. Then we pass from the first law of thermodynamics to the second law, where we explain what we call the entropy, delta S, and then we pass to the free enthalpy, delta G. Any reaction has a value of delta H, delta S, and delta G. From the value of delta H, we can know if the reaction is endothermic or exothermic. From the value of delta S, the entropy, we can know if the reaction, when passed from reactant to product, the order or the disorder increase. And from the value of delta G, from the sign of delta G calculated, we can conclude if this reaction is spontaneous. Spontaneous means it could happen automatically without external effect. Non-spontaneous, this reaction could not happen if we don't do, for example, external effect. So this is the main objective. This is the fruit of the chapter 5 and chapter 6, to calculate delta H, to calculate delta S, and to calculate delta G. So the first part is notation. We have to define important terms. What is thermodynamics? On May 6, 1937, the German airship filled with hydrogen exploded during a leading attack. The airship was filled by hydrogen, and since hydrogen gas is a light gas, so it's useful for this type of airship. But the airship was to have been filled with helium and not with hydrogen. The helium sales to Germany at this time has been suspended. For this reason, instead of using helium, which is a light gas, the German used hydrogen. But we know that the hydrogen H2 react with oxygen of air, and this reaction is highly exothermic. So this is an example about the calculation of heat of the reaction between hydrogen and oxygen. This calculation of the energy changes that occur during this chemical reaction or during any chemical reaction we call the thermochemistry. So the thermochemistry is the calculation of the heat or the energy released or absorbed from a chemical reaction. The thermodynamics is a Greek word from thermi, that means heat, and dynamis, that means power. So the thermodynamics is the science of heat and work. So the main objective is to calculate the heat of a transformation and the work during a transformation. We have two types of transformations: the chemical and the physical. In the chemical transformation, we have reactants that are transformed to product. So this is a transformation that took place by changing the composition of the system. I have A and B initially. In the final state, I have C plus D that are different from A and B. So this is a transformation. The chemical transformation is a transformation with a change of composition. The physical transformation, consider for example ice that melts. So we have H2O solid that is transformed to H2O liquid. So the state of the system has been changed without changing the composition. Initially, we have H2O, and in the final state, we have H2O. So the composition is the same. But we have a change in the state of the system. The system was initially solid, and in the final state, the system is liquid. So this is a physical transformation. Pay attention that in thermodynamics, the concept for chemical or physical transformation are practically the same, are close, but the calculations of the energy change in the chemical is different from that in physical. So in any exercise, the first step is to know if the transformation in this exercise is chemical. So we have to follow the rules to calculate the energy change for chemical, or it's physical, you have to use the rules of the physical transformation. Is thermodynamics an indication about the speed of the reaction? No. The thermodynamics of a reaction tell us if the transformation could happen without external effect. So if the transformation is spontaneous, or if the transformation is non-spontaneous, so it could not happen in the condition given. So thermodynamics give us indication about the spontaneity of the reaction. The rate of the reaction can be obtained only from the chemical kinetic. So first, if we know to study the kinetic of a reaction as in grade 12, we have to know if the reaction is possible or impossible. So we do first thermodynamics studies. We know if our reaction is spontaneous or non-spontaneous. In other words, if our reaction is possible or impossible. If we find the reaction possible, so we can pass to study the kinetic of this reaction by the chemical kinetic method. Important definitions. First, what is the meaning of a system? A system is a well-defined part of the universe where the transformation takes place, and any system is characterized by several properties, for example, by temperature, by pressure, by volume, and by number of moles. The surrounding is the remaining part of the universe. Suppose I have a student in a classroom. The classroom is the universe. The student is the system. The figure classroom minus this student is the surrounding. So if the system is if the student is the system, all other students around are the surrounding or is the surrounding. System and surrounding will constitute what we call the universe. What is the transformation? A transformation is the path from one system state to another system state. I return to the example of the student in the classroom. The student is in the first stage. He passed to stage number 10. So the student make a transformation. Why? Because he passed from his system all well-defined properties to the system of another defined properties. So this is a transformation. It's the pass from a system of certain properties to the system of different properties. In thermodynamics, we study the exchange of energy between the system and surrounding. Suppose I have system, the system is in blue, the surrounding is in yellow, and all this box is the universe. So if the system release energy, this energy is absorbed by the surrounding. And if the system absorb energy, so the system absorb energy from the surrounding, or the surrounding release energy to the system. So the energy change in the system is related to the energy change in the surrounding. Okay, I have, for example, 10,000, okay, and another student is close. I give this 10,000 to the student. So I can say, I am the system. I lose 10,000. So I release 10,000, or I can read it in another way. The other student, which is the surrounding, absorb this 10,000. So this is exchange between the system and the surrounding. The system is three types. We have open system, closed system, and isolated system. What is the open system? The open system is a system that exchanges energy and matter with the surrounding. For example, consider a candle. The candle, which is a system, release energy to us, and we are the surrounding. At the same time, when the candle release energy, the candle will lose matter. So the candle is an open system. Closed system is a system that exchanges only energy and no matter with the external, with the surrounding. An example of a closed system, the heater. The heater is a system, and we are around the heater, so we are the surrounding. The heater release energy to the surrounding, but never release mass, never exchange mass, because the mass of the heater is the same. So the heater is a closed system. And the third system is the isolated system. This is a system that did not exchange energy nor matter with the surrounding. For example, if you consider the calorimeter, what we call thermos, the calorimeter, you put, for example, inside you put coffee. the coffee did not exchange matter with the external because the volume and the mass are constant. At the same time, the temperature of the coffee is the same. So it does not exchange energy with the external. This is an isolated system. The transformations are two types. The reversible transformation and irreversible transformation. Reversible transformation means you have transformation in direction 1 and transformation in direction 2. So this is a reversible. It took place in the two directions. The reversible transformation is slow, success of infinity of equilibrium state, takes place in two directions, in the forward and in the opposite direction at any instant, and pay attention, passing by the same equilibrium state as the forward direction. I will ask a question. In grade 12, you studied the equilibrium, and you said that the equilibrium is a reaction that takes place in two directions, and sometimes you called reversible reaction. This is incorrect concept. Why? In grade 12, the reactions takes place in two directions, but the conditions in direction 1 are different from the conditions in direction 2. So this reaction takes place in two directions at any instant, but we don't have the same equilibrium state in direction 1 and direction 2. So all examples studied in grade 12 are not reversible. This is a reaction only, we can say this is a reaction taking place in two directions. But the conditions in direction 1 are different from the conditions in direction 2. So this transformation is not reversible. We call it, this is inversible transformation. The equilibrium examples in grade 12 are inversible transformation. What is the meaning of inversible? It means that you have reaction or transformation in two directions. If the transformation takes place in two directions and the conditions in direction 1 are exactly the same in direction 2, so this transformation is reversible. We have in the reversible, we have absence of dissipation process. The reversible transformation did not exist in the reality. So all transformations are practically not reversible in our nature. Some transformations tend to be reversible, but could not be. The irreversible transformation is a transformation taking place in one direction. For example, A plus B gives C plus D. So A plus B react to give C plus D, but C plus D could not regenerate A and B. This is a reaction in one direction. What is the meaning of isothermal transformation? The transformation could be realized at P constant, or at T constant, or at V constant. Isothermal is a transformation that is realized at temperature constant. Isobaric is a transformation realized where the pressure remains constant. And isochoric is a transformation realized at V constant. I will make a summary for the previous slides. System is a point of the universe. Surrounding is the remaining parts around the system. System and surrounding constitute the global universe. We are interested in the transformation of the system or of the transformation of the surrounding. But we have to keep in mind that when the system transformation releases energy, this energy is absorbed by the transformation that will happen in the surrounding, and vice versa. So the system releases energy to the surrounding, or the system absorbs energy from the surrounding. It depends on the nature of the transformation. The system is three types. We have a closed system, exchange of energy with the surrounding and exchange of matter. We have open system, exchange of energy and matter with the external, with the surrounding. Closed, we have only exchange of energy with the surrounding with no exchange of matter. And isolated, we don't have exchange of energy between system and surrounding, nor exchange of matter between system and surrounding. Transformation. What is the meaning of transformation? When you walk, you make a transformation. Why? Because before walking, your properties are well defined. When you walk, for example, the distance is changed, so you make a transformation. A transformation is a pass from a system of known properties to another system of different properties. We can have, for example, several properties that are changed, but we need at least one property to be changed in order to talk about transformation. And the transformation realized at T constant is called isothermal transformation. The transformation realized at P constant, isobaric. The transformation realized at V constant is called isochoric. The transformation is also two types. We have reversible and irreversible. If you make a transformation by changing, for example, your temperature 5 degrees by 5 degrees till the end, and then you return to the initial by decreasing the same order, by decreasing 5 degrees by 5 degrees by 5 degrees, so this transformation is reversible. The change of the properties in direction 1 are the same as in direction 2. If you make a transformation in direction 1 and you return in direction 2 with different conditions or different properties, this is inversible. And if you make the transformation only in one direction, this is irreversible. I pass to other definitions. As we said, a system is characterized by properties, energy, for example, energy, pressure, volume, temperature, composition, number of moles, all are properties. What is the definition of a state function? A state function is a property where the changes in this property during a transformation depends only on the initial and the final states, and it does not depend on the path. I will consider this example. I have 2, 4, 6, 8 persons that will pass from down to up. I will consider these two persons, person 1 and person 2. The first follow the path 1. This is path A, 12 miles. And the second person follow path B to reach the same point 12 miles. So these two persons make transformations. What are the properties changed during this transformation? The first property is the path, is the distance. And the second is the height. These two persons follow different distances, different paths, but they reach the same height. So the height is a function that depends only on my initial state and my final state. It does not depend on the path I follow. Student A follow path A, student B follow path B, and path A is different from path B, but the height of student A is the same as the height of student B. So the height is a state function. It does not depend on the path I follow. It depends only on my initial state and my final state. So this is a state function. The distance is not a state function because the distance does not depend on the initial state and on the final state. It depends on the pathway I follow. So in this figure, I have two properties, the height and the distance. The height is a state function, the distance is not. So the change in height is a state function, the pathway is not. This is very important definition, the state function. I pass to other notations. What are the forms of energy? First, what is the definition of energy? The energy noted U or E is the capacity to do work. The work is the force acting over a distance. So the energy is a work is equal to the force times distance. The kinetic energy is a form of the energy. It's the energy of motion. The potential energy is another form of energy that depends on the position, on the composition. It's in general associated with the forces of attraction and repulsion between objects. In the physical transformation, I use usually the term work, kinetic energy, and potential energy. So in the physical transformation, they ask us, for example, to calculate the work, to calculate the kinetic energy, or to calculate the potential energy. In chemistry, we are interested about the calculation of the thermal energy, of the energy or the heat released or absorbed during a chemical reaction. So the thermal energy is the kinetic energy associated with the random molecular motion. And the chemical energy is the potential energy due to the structures of the atoms, the attachment between atoms, the atoms' positions to each other in the molecule. For example, consider A plus B that gives C plus D. How A and B are transformed to C and D? First, in A we have bonds, in B we have bonds. The first step is the breaking of these bonds. So in the chemical reaction, we break a bonds and we form new bonds. And this bonds broken has a certain energy, and the bonds formed are different energy. So what we calculate is the energy of this reaction is the difference between the energy of the bonds of the products and the energy of the bonds in the reactants. So as a conclusion, in the physical, we calculated the work, the kinetic energy, the potential energy, and in the chemical reaction, in chemistry, we calculated the chemical energy, which is in general thermal energy.